the screen capture as usual. So the screen capture will still be on YouTube, but without the audio. When I get home, I would use the audio file from my phone and then splice it with the video file that I would download from YouTube. Combine the two. I'll sync it, okay, so that it's not like Chinese Kung Fu movie where you see the action and then you see the mouth moving a little bit and then you hear something about it, right? So it's going to be synchronized to the best I can. Sometimes they are off like by a few seconds, from the beginning to the end, so there might be a little bit of offset, but hopefully it's not going to be too bad. All right. So I don't know how many of you watched the video that I recorded over the long break.
I think the first 5 minutes.
Sorry? Huh?
There were 2 videos?
There were 2, but I didn't advertise because supposedly I cannot teach the class during the break. Even online classes are canceled officially.
Whoa.
Yeah.
I didn't know that actually. I did a whole bunch of homework over the break.
Yeah, so I also redid some of the notes for local variables and parameters, so they look consistent with the spreadsheets that we're going to do now. All right. So we'll first recap what we had talked about in terms of invoking and returning from subroutines. Hello? All right. And with this classroom, I can open up the entire page, because with some other classrooms, the screen is too low, so I can only use the top, like 2/3 of the screen. But this classroom is a little bit better. The screen is hung high enough for that. Okay, so this is just the subroutine and the control flow, which we talked about before the break. Okay, so this is really just a quick rundown of how to invoke a subroutine and how to return from a subroutine. Okay. So the quick, so instead of reading this stuff, I'm just going to work out an example. We'll use a new window to display the trace. So one is going to take, one is going to display the algorithm, the other one is going to display the trace. So we'll use this one to specify the algorithm. A subroutine it starts with a definition, so we say define sub, and then the name for the subroutine. We'll just call this one ABC in this case. And we'll just do something kind of boring. X gets x plus 1, and define sub. And then outside of the subroutine, so we'll just kind of do it this way for this program. So x is a global variable, and then we invoke ABC, and we'll say x gets x times 2, invoke ABC again, and we'll indent one line. There we go. So we have the algorithm, and then now we go for the trace. So with the trace, hopefully you guys still remember the convention for the trace. We have one column for the line number that we're executing, one column for the global, for each global variable. In this case, we have one global variable, which is x. So x takes up a column. And the precondition is we do not need to know anything about x, so we put a question mark here.
Hello.
And it's okay, I just did that in my previous class. Well, I do allow certain calls through. As it turns out, it wasn't important, so I had to turn off my phone entirely. So the first line to execute is the first line that is outside of the definition of a subroutine. The definition of the subroutines goes from line 1 to line 3. So line 4 is the first line that is outside of the definition of a subroutine. So we start with line 4. Line 4 is initializing x to 0. And then line 5 is our first invocation. When we invoke a subroutine, we allocate a column for return line number. Okay? We always allocate the leftmost available column, which means we can use a column, but then we can deallocate a column. So we use the leftmost available column. We label it return line number, and then we write down the line right after the invocation. The invocation is on line 5, so when we get back from the invocation, we should continue on to line 6. So the return line number is line 6 in this case. This is how the subroutine can figure out where to go back to when it is when it's done executing. And then we continue execution in the subroutine. Since we're invoking ABC, and there's only one subroutine here with the name ABC, we go into the subroutine on line 2. Line 2 doesn't do much. All it does is to add 1 to x. X goes from 0 to 1, and then we go to line 3. Normally, we do not trace any line like end if, end while, stuff like that. But with subroutines, we do, because end defined sub has significance. Because by the time we get to end defined sub, we have to figure out, hey, we're at the end of a subroutine. Where are we supposed to go back to? So the way you figure out where to go back to is to locate the rightmost column that is still labeled return line number. In this case, it's column C. And use that to help you to get back to the line that you're supposed to go back to. Column C tells us that we have to go back to line 6. So we write down line 6 here. But after that, we have no use of column C anymore. The entire purpose of column C is to tell us where to go back to. Now that we have used that information, we are deallocating column C. So in this class, the way we represent this column is no longer in use is to use strike through as a font to basically say that this column is now deallocated. Now execution continues on line 6. Line 6 says we want to double the value of x. X goes from 1 to 2 because of that. And then on line 7, we have another invocation. So once again, with an invocation, we allocate the leftmost available column. Column C is once again available because it was deallocated on row 7 of the spreadsheet. So now it is available again. So we'll reallocate column C, label it the same way, return line number, and then this time we have to write down post because there are no other lines after line 7. So that means when we get back, we're done with the entire execution of the program. And then we continue execution in the subroutine from the beginning, which is line 2. Line 2 says add 1 to x. X goes from 2 to 3. We go to line 3. Line 3 has to do 2 things. One is to locate the rightmost return line number column, which is column C. It tells us that we have to return to post, so we write that down first. And then we deallocate column C. And then we quote-unquote continue execution, but because post indicates we are at the end of the execution of the entire program, we're actually done at this point. So this is a quick recap of calling or invoking a subroutine and also returning from a subroutine. So this mechanism is the basis of every topic about subroutines. So do we have any questions about this particular trace? No questions? Okay. And then we talked about local variables, and then we started to talk about parameters. So what we'll do next is to get into parameters, or better yet, we can get into return values. Okay. So in the notes, okay, let me point out where we are in the notes. So in the notes, what I just demonstrated is invoking and returning. We already talked about local variables and parameters. I believe we talked about, did we talk about passing by reference? I don't think we touched on passing by reference yet. Okay, so that would be a good place to kind of resume that discussion. And if you go into these notes here, you might notice that the format of the trace has changed to be more consistent with the way I use spreadsheets in class. So I think that's a good thing because now the notes that you can print out, in PDF is actually consistent with the way I demonstrate traces in class. Are there any questions about this? The column annotation is not needed when you turn in your homework assignment or in your final exam. You do not need an annotation column to explain everything. It is only here because I need to explain all the tricky things that are going on as we execute the code. Okay, so I believe this one is done already. Okay, this is the trace where we have 2 subroutines. Each one is going to do one thing twice. the first one is going to call the other subroutine twice, the other one is going to print x twice. I believe we are done with this particular one. And then the next one talks about parameters. And here we have a sub1 that has a parameter of n. Did we talk about this in class? Nope. Okay, so this would be a good one to start with. So a parameter is something that that the caller can specify in the invoke statement. In this particular case, on line 11, the invoke statement says, oh, parameter n should start with a value of 2. And on line 12, the same sub1 is invoked, but this time we use 1 to specify parameter n. Parameter n is designated as a by val, which means by value. There's another type of parameter called by reference. We'll talk about that next. So for the most part, you can look at it as a local variable. So n is just like a local variable, kind of like I, with one exception. The value of n is specified by the invoke statement. The value of I is always unknown. Okay? So when we use n and I inside the subroutine itself, we access both as if they are just kind of local variables, except one is initialized by the invoke statement, the other one is not. So we'll go ahead and trace this code in the spreadsheet, and that will give you a chance to ask questions as we go through the trace. So I'm just copying the code here. Instead of copy and pasting, I'm just rewriting everything, because sometimes copy and pasting doesn't work like this. So all right. So this is the code. This is going to be the trace. We move this one here and fix the indentation a little bit. Alright, so this is the algorithm, and this is going to be the trace. Once again, we have line number. This time we also need comments because we do have a loop, so we have a condition to evaluate. And we have no global variables this time. Okay, there are no global variables because when you look at all the things that we can change values, I is a local variable, which means it is not a global variable. N is a parameter, which also means it is not a global variable. So there are no global variables in this particular program. So the precondition really has nothing to say because there's nothing, there are no variables to say anything about. Once again, we start execution on the first line that is outside of the definition of a subroutine, which is line 11 in this case. Line 10 official is the first line, but since it's blank, we're not going to trace it. So on line 11, we do an invocation. So once again, we allocate the leftmost available column for return line number. This time we're returning to line 12. But we are also going to allocate 2 more columns. One column is for the parameter n, the other is for the local variable I. The difference is with a parameter, the value is specified by the invoke statement. When you look at the line 11, the invoke statement says n should start with a value of 2, and therefore that's why you see a right arrow to the name of the parameter. So n starts with a value of 2 because it's a parameter, but I is a local variable. It always starts with an unknown value. So do we have any questions about this part of the trace? Yes?
Is it wrong to do n left arrow 2, or would it mean the same thing?
I suppose you can do it that way, because the arrow is just indicating which way information is flowing.
Yeah.
Yeah.
say that n is already established, even though the define hasn't, like we haven't traced n, so n is being invoked in line 2, even though it's already been, it's like it's there, but we haven't invoked it, so we're assigning 2 to n.
So line 2 does not actually quote unquote execute. All it does is declaring the name n is the name of a parameter.
Okay.
And then on line 3, all it's saying is we have a local variable I. But it doesn't really do anything per se. It really is just saying, you know, what the subroutine needs. Okay. Any other questions? Okay. So now we continue execution in the subroutine starting on line 4. So line 4 is initializing I to 0. And then line 5 is the beginning of a loop. So we have to evaluate the condition. I is less than n is, what do you think? Is it true or not?
True.
It's true. Very good. So we go to line 6. Line 6 really doesn't do anything, you know, other than just, you know, printing, you know, x to the screen. And then we proceed to line 7. Line 7 is just adding 1 to I. So now we put 1 into here. Then we go back to line 5. I is less than n is still true because 1 is less than 2. Then we go to line 6 again. It prints another x to the screen. We go to line 7 again. And this time I gets incremented to 2. So 2 is less than 2 is false. So this time when we get to line 5, I is less than n is false. We get out of the while loop. There's nothing after the while loop in the program. So we go straight to line 9. When we get to line 9, we have 2 things to do. One is to know where we are supposed to go back to, because this is the end of a subroutine. We track down the rightmost return line number column, which is column C. It tells us we have to continue execution on line 12. So we make a note of that. And then we don't have use of these columns anymore. This time all 3 columns should be deallocated, because the return line number, the local variable I, and also the parameter, they are only needed for each invocation. At the end of an invocation, we deallocate all of those columns. So those columns can all be used again if we need to. So we copy and paste all that stuff here, and then use strike through to indicate that these columns are now quote-unquote deallocated. Then we continue execution on line 12. Line 12 is another invocation of the same subroutine. So we're going to do the same thing. We allocate the leftmost available column and label it for return line number. And then we have parameter n and local variable I again. This time the return line number is post because we don't have anything after line 12. N is 1 because that's what the invocation wants to specify, is parameter n should start with a value of 1. And then I, as a local variable, always start with an unknown value. So are we still doing okay so far with this trace? Okay. So after we set up all of this stuff, we continue execution in the subroutine. In the subroutine on line 4, that's the first line of code, we initialize I to 0 again. So the question, some of you may have the question, but don't we have a 2 on this column already? The answer is yes and no, okay? So technically speaking, you know, when you execute this program in an actual program, yes, column E, quote unquote, still has a value of 2, but you would not know that, okay? You cannot assume that. So basically, with local variables, every time you invoke a subroutine, you should assume the local variables are all unknown. Okay? Yep.
So after you invoke sub1, why don't you go to line 2 and then establish n as 1, and then line 3 establish I, and then line 4 I is 0, and then go into your loop? Why do you do it all on line 12 there?
Because it doesn't really happen in that particular order. If you want to specify the order, it's actually n that allocates a column first, and then the return line number, and then L is the last one to allocate a column. But in this class, we are not concerned about the ordering of all of those things. We just say that each one occupies a column in the spreadsheet. But which one goes first and which one goes second we're not gonna,
And that all happens on the invocation.
right. Yep.
Okay.
Mhm. By the time you get to cisp300, then we will actually look at the ordering and understand how it's done in the computer. But in this class, we just know that, with each one, we need to dynamically allocate a column for each one of those. Is that okay? Okay. So on line 4, we initialize I to 0. So for the most part, there's nothing really exciting here. On line 5, we perform the comparison. I is less than n is true. We go to line 6, it prints x once to the screen. We go to line 7, it increments I so that I goes from 0 to 1. And then on line 5, we go back to line 5, I is less than n is now false. And then we exit the loop, we get to line 9. So once again, when you get to the end of a subroutine, you got two things to do. Look up the rightmost return line number column, which is column C in this case. It says post, so that means we have to go back to post when we're done. And then we have to remember to deallocate these 3 columns. So I'm just being a little bit lazy here and copy the ones that already have the strikeout effect applied.
What's
Or-
the key sequence you're using to copy all 3 of those cells?
So one click on this cell, and then shift click on the last cell, and then Control C to copy, and then Control V to paste.
I just want that on line 9.
Oh, right. There you go. There you go. And once this is done, we continue execution, but post means we're all done, so that ends the entire trace. So do we have any questions about this trace? This one has got the addition of a local variable, which we have already talked about before the long break, and also the concept of a parameter. N is a parameter. So the difference between a parameter and a local variable is really just one starts with a particular value specified by the invoke statement. The other one does not start with any particular value. And it's up to the subroutine itself to initialize. There was a question. Yep.
Yeah, and those are just, and those 2 variables N and L are deallocated just because they are part of the subroutine itself.
It belongs to the invocation
Yeah.
of the subroutine.
Okay.
Yep.
Okay.
So basically, it's every time you invoke a subroutine, it's kind of like writing all your math out on a chalkboard, and then once you're done working out that math, you just erase it all.
Yes.
Well, isn't that when you end the subroutine?
Mhm.
Yeah.
You start the subroutine and it creates the variables. When that subroutine ends, the variables that it created go away.
That is correct.
Okay.
Mm-hmm.
Alright.
Is that good?
Yeah.
All right. Cool.
So, parameters only exist when you need a variable, an undefined variable in a subroutine. That's the only thing they're used for. So, like purpose?
Okay. So in terms of purpose, a local variable is a variable that only has use inside a particular subroutine. So that's why only that subroutine has visibility of the variable, and that's also why the variable only start to exist when the subroutine is invoked. Okay, the purpose of a parameter is different. The purpose of a parameter is so that you can specify additional data for an operation. So let's say you
It's
add.
almost a placeholder?
It's kind of like a placeholder.
Okay.
It's a placeholder where the value of the placeholder can only be determined when you invoke the subroutine. So there's no way for the subroutine itself to say, oh, I'm going to start with this value, because it doesn't make any sense. How many times, for instance, in this one, to print X. So somebody else has to specify that. Yep.
Also earlier when you said someone was asking the question, like the variable, was it L?
It's actually I, but
Yeah,
it automatically
someone said L, someone else
capitalized.
confused.
Yeah.
That had the value of 2 in the prior subroutine that was like deallocated. But then you're saying it's you just always assume that it's like unknown.
Yes.
Are there cases where like the prior value will affect what's going on in a subroutine that occurs after that one has been deallocated?
So with any type of proper programming, you should never ever rely on the uninitialized value of a local variable. Okay, so unless you, as a subroutine, initialize and put a value into a local variable, you always say, I have no idea what is in that variable at the entry point of a subroutine. Okay? Now I said, in the proper use of a subroutine, because if someone is not writing a program correctly and make certain assumptions or start to use a variable when it is not initialized, it might pick up certain things from previous invocations. Kind of like ghost data.
Yeah, that's what
It's kind of like there, but it's not always there. It's not reliable. And that can be a security risk because the prior invocation of a subroutine may be storing a password or encryption key or something like that. So having that stuff left behind but not initialized to be overwritten with means you could potentially expose sensitive data when it's not supposed to be accessible. Yep.
Can you use a global variable as a parameter?
Okay, so let me rephrase your question and see if that is what you're asking. Can we communicate between a caller and a subroutine using global variables? Is that kind of what you were asking?
Kinda, yeah.
Okay, the answer is yes, but it's not a good idea. So let me explain to the class what the question is. So the question is, instead of using a parameter, like in this case by val n, can we use a global variable, let's say n, so that the main program here would put a value of 2 into it, and then the subroutine would just pick up whatever n has inside the subroutine? The answer is yes. But any global variable that you use in a program is most of the time a bad idea. And the reason is, the more you use global variables, the more likely the global variable is modified by some subroutine without you knowing it. Is that okay?
Yeah, so if I use the global variable as a parameter, the value of the global variable is going to change.
It can be changed by any subroutine, because as the name implies, a global variable is accessible to every single part of your program. So you can no longer restrict the reading or the writing of a global variable to just a portion of the code. But with parameters, parameter n is only accessible within sub1. Nobody else has access to it. Yep.
So does that mean that if a subroutine is running alongside of another subroutine, that it can overwrite that value between the two
Okay, so you have to define what is running alongside with.
at the same time? So, because I don't understand, like, if you declare n in that subroutine and it goes away when it ends its definition, then what's going to change it?
What's going to change?
It would have to be something else running outside of that subroutine, something running at the same time, right? So how would something change those two values if you just wrote like,
But why would anyone other than sub1 want to change those two?
Well, I don't know.
The idea is I is a local variable in this case, so only sub1 has access to it, and only when sub1 is invoked, I exists. Okay?
Right,
When sub1 is not invoked, I does not exist.
right.
Okay? And n is kind of the same thing, because when sub1 is not invoked, there's no meaning to parameter n. I mean, who's going to make use of it?
Why can't we say local I and local n, or n equals, well, I guess, no way, you can't say it.
Because it would
Why
need
can't we just say local I and local n?
Where?
On line 2.
On line 2?
We wouldn't use local n because n is a parameter that can be inputted by outside the subroutine. Like I is just a counter. The by val n is just that someone is putting in a number to test the subroutine to see how many times it'll print.
One is kind of like an inbox, and the other one is a little pad of paper that you use inside an office. So the inbox takes in documents from somebody else, so it is a source that the subroutine has no control over. Okay? But then inside an office, you can have your little notepad, so you can jot down notes as you work on something. That's your local variable. So you can look at a parameter as quote-unquote an int array, and then you look at local variables as notepads that is inside an office, but people outside of the office should never have access to the notepad inside an office. Would that make any sense?
Starting to.
Okay. I hesitate to use analogies because some of these analogies can only be pushed so far, and then beyond a certain point, you know, the analogies actually would not work. So it's actually counterproductive at a certain point. Yep.
You mentioned by ref as another means of a parameter.
Mm-hmm.
The difference between a by val and a by reference is?
I'll illustrate it next. Okay. But before we move on any further, is this program okay? It's okay so far? Okay? All right. So if this is okay so far, then we'll start to go into an example to illustrate why by val it's not sufficient. Okay? Why we need by ref parameters. So we'll define a swap subroutine here. Define sub swap. It has by val x, by val y, local t. So x and y are parameters. T is a local variable. And this is a pretty typical sequence of exchanging the values of two things. T gets the value of x gets the value of y, and then y gets the value of t. And you will see that this actually works. And then outside here, we have define sub main. So from here on, I'm going to start to use the concept of a main subroutine. I'll explain that a little bit later. Okay. So we have local, I don't like I because it automatically capitalizes I, so we'll use M and N, okay, so we have M, local N, okay, M gets a value of 15, N gets a value of negative 20, and then we invoke the swap subroutine, using M to specify parameter X, using N to specify parameter Y, and define sub, invoke main. Okay, so there are several things about this program that are kind of important. Some of this is actually mentioned in the video that I recorded over the long break. So some of you may feel that, hey, you talked about this already, but the rest of the class may not, you know, watch the video. So this may be new to some people. All right, so there we go. Okay, so the first thing about this, interesting about this program is when you move on to cisp300 in C and C++ programming, there's always a main function or the main subroutine, and that's always going to be invoked automatically. Okay, so this program is mimicking what you will probably end up dealing with in a typical C program. So that means, you know, everything that you want to do start with main. The invoke main in the case of C and C++ is implicit. You don't actually see that. So when you have any code to specify, you always start with putting it into main. Is that okay?
Yeah,
Sort of?
start with what? Always start with what? What is it?
Okay, so in the C and C++ program, you cannot have any lines of code outside of the definition of a subroutine. Which means, hey, but then where do we start? As it turns out, the name main has a special meaning. Whatever subroutine is called main is always the function that is always the subroutine implicitly called first. So that main becomes the entry point of your program. Is that okay? So what I'm trying to do here is to mimic that particular effect in C and C++. Okay? Yep.
Is main the only indicator for that subroutine to make it main? Is there anything that you would say for the other subroutines that would indicate that it's not the main?
The only thing that is different is the name. So if you name a particular subroutine main, then the compiler will identify that as quote-unquote the special subroutine, and it becomes the first subroutine being called. Now it can call any other subroutine, even itself if it needs to, but that becomes the entry point of the entire program. Okay, so that's one thing that you have to kind of remember in CISP360 because it's not the same as what we have been using in this class. All right, so let's go ahead and trace this program and see how it doesn't get a job done, okay? So this program has the correct logic, but it has the wrong kind of parameter, and as a result, the program doesn't work the way it's supposed to. It does get certain things done, just not what we want in the end. So I'm just lining up the spreadsheets so that we can show that here. All right, so line number, typical stuff. Pre has nothing to say because we do not have a single global variable. The way you analyze whether we have global variables is to look at everything that can contain a value. M can contain a value, N can contain a value, but they are not global variables. Why not? Because they're declared local. X, hey, looks like I can store something into X, I can store something into T, I can also store something into Y. Why are they not global? Two of those are parameters, and one is a local variable. So we do not have any global variables, which is the way I like it. Okay? Yep.
So the other reason that there are no global variables is because they're not defined outside of the subroutine.
They're not global variables because they are either parameters or local variables. A global variable in this class would be a name that is not a parameter and it is not a local variable. In the regular C and C++ program, you actually have to define or declare the variable outside of a definition of a subroutine to make it a global.
Right.
Okay. So there's not much to say about the pre. Then we start execution on line 16, which is the only line outside of the definition of a subroutine. So we have a return line number of post, pretty easy on with column B. But then we also have to allocate for each local variable and parameters, if any. So this time we only have two local variables. One is M and one is N. And because they are local variables, we always assume we do not know their initial values. And we use a question mark to represent that. Then we continue execution in main, starting on line 12. M gets a value of 15. On line 13, N gets a value of -20. So nothing really surprising here. And then we get on to line 14. Line 14 is the invocation of the swap subroutine. So we do the usual stuff. We allocate the leftmost available column, label it return line number. And this time we are returning to line 15. So we write down here the return line number is line 15. That's column E. But we also have to allocate for each one of the parameter as well as local variables. The parameters are X and Y. So we got X, we got Y, and then the local variable is T. X is passed by value, which means whatever you use to specify parameter X, you're making a copy of that. Okay, you're copying the value of whatever you specify to the parameter. And that's why it's called pass by value. Okay? So you look at line 14, and you look at the expression that you use to specify the initial value of X. Well, that's just M, okay? But you know what? If I want to be pointless, okay, I can always change this from M to M plus 0. I can always change this N to N times 1. In other words, whatever you use to specify a pass by value parameter only has to be an expression. Can be any expression. Is that okay? It doesn't have to be a constant, doesn't have to be a particular variable. It can be any general expression. Is that okay? So what is M plus 1? Well, M has a value of 15, plus 1 is also 15. So X starts with a value of 15. What about Y? What is the initial value of Y? What is N? N is -20. What is -20 times 1? -20, okay? So Y also starts with a value of -20. In other words, it is very important that we do not specify M plus 1 here. We do not specify N times 1 here. We evaluate the expression. Whatever the value of the expression is, we use the value of the expression. Has to be numerical. Is that okay? Yep.
So if on an exam, we don't do n plus 0 and n times 1, if we don't convert the assignment statement there in that implication into an expression, do we get it wrong?
Well, typically in an exam, I will give you this code and you have to trace it. I only put a plus 0 and a times 1 here to emphasize whatever you use to specify a by-value parameter can be any expression. It doesn't have to be a constant like 1, 2, 3, 4. It doesn't have to be a variable like in this case m or n. It can be an expression of any kind. Okay? Yep.
Does that include strings?
Strings are in a way just like this, but strings are arrays. They're arrays of characters, and each character is a number. Because we are talking about ASCII code, so it's a little bit out of scope with what we are talking about here. And we can't really talk about strings or arrays until we get to by reference. And that's a little bit odd stuff about C that kind of puts that limitation on. What is T, by the way? T is a local variable, so its initial value is unknown. Okay? So now we kind of compact the columns a little bit. There we go. And now we can go into the subroutine call swap. T gets the value of x. X is 15, so T is now 15 on line 5. So T is 15. And then on line 6, we copy the value of y to x. Y is negative 20, so x is now negative 20. And then on line 7, we copy the value of t to y. T is 15, so y is now 15 as well. So if you think about it from the perspective of the subroutine, the swap sequence worked. Because x was 15, y was negative 20, and now x is negative 20 and y is now 15. So it seemed to work, okay? But what happens when we get to line 8? Tell me what's going to happen. What are the two things we need to do on line 8?
You need to exit the subroutine. Exit the subroutine.
We need to exit the subroutine, so that means we have to use the rightmost return line number column to tell us where to go to continue execution. So that's line 15 here. We make a note that we have to go to line 15 next. And then what do we need to do?
Deallocate.
Deallocate. Very good. So we have 4 columns to deallocate this time. So we do a Control C, Control V. I wish there was a shortcut key to do the strike through, but that's okay. And now these 4 columns are gone. Columns E, F, G, and H are gone by the time we get back to line 15. Did we do a single thing to local variables m or n in main? Okay. So was there any point in calling or invoking swap?
No.
Did it do anything that was of significance to main?
No.
Not a single thing. Okay. Well, we finished tracing this code and then we'll make some slight modifications and then we'll see how by reference is going to change that. Okay? So on line 15, it is also an n-defined sub. We look up the rightmost return line number column, which is now column B, and that's because column E is gone now. So column B becomes the rightmost return line number column. It tells us we have to continue at post, and then we deallocate everything that is specific to this invocation. So we copy and paste, and then we change all of these to strike through, and then we continue at post, which means we're all done. Yep.
So we didn't do anything that actually changed the values of m and n. In a trace, is there any reason why we need to indicate that to show that we understand it?
Nope, this is sufficient.
Okay.
Because we can see that the value of 15 stayed with m the entire time, and then the value of negative 20 also stayed with n the entire time. So there's no particular reason why you have to kind of note that separately. So is that okay so far? Does everybody understand why it did not work? It did not work because parameter x and parameter y being passed by value parameters are copies of m and n respectively. Okay, so as we make changes to x and y, they did not affect m or n at all. It is almost like, somebody is giving you some paperwork to process. The first thing you do is you make a photocopy of that. And then you start to mark up everything on the photocopy. And then when you're all done, you put the photocopy, the marked up paper photocopy to the recycle bin. And then you give the original paperwork back to the person. That's basically what passing by value is doing. It's great for certain things, okay? If you need something that you don't need back anymore, okay, to the subroutine to work on something, that's perfectly fine. But on the other hand, if you are expecting the subroutine to change something and then give you the changed or modified item back, then passing by value is not going to work. Is that okay? All right. So if this is not going to work, how are we going to fix it? Well, we fix it by a mechanism called passing by reference. So now we are starting to change the program, but only very slightly. We change the word by val into by ref, which is by reference, and same way over here. And then just for notation purposes, okay, there are two things here that are really important. When you're passing by reference, you can no longer pass an expression. You have to pass a variable, something that can store a value, to the parameter. We also changed the arrow, so it's now a double-sided arrow to kind of emphasize that whatever you do to x is happening to m. Whatever you do to y is happening to n. Okay? So these are the new restrictions. If you're passing by reference, whatever you specify to the parameter that is passed by reference has to be something that can store a value. It has to specify a column when you trace the code. n plus 1 does not have a column. n plus 0 has no column. n times 1 does not have a column. But on the other hand, m has a column corresponding to it. N also has a column corresponding to it. Is that okay? All right? And we are changing the arrow from a one-sided arrow to a double-sided arrow just for additional notational purposes. So that's really just to emphasize that changes are both ways. Okay? So now we'll start a new trace. Return line line number is pre. Okay, there's nothing to say because we still do not have any global variables. And then we get to the first line that is outside of the definition of a subroutine. Same thing on line 16. Okay, no change here. It is invoking a subroutine, so we got to do the same thing as last time. Allocate the leftmost column as a return line number. One column for m, one column for n. The local variables always start with unknown values, or we always assume that we do not know what they are. And then the return line number is post, just like last time. So we haven't really done anything differently this time up to this point. We go into the subroutine. On line 12, m gets a value of 15. On line 13, n gets a value of negative 20. No change at this point either. When we get to line 14, we have to allocate, because it's the invocation of a subroutine, we allocate the leftmost available column labeled return line number, and it has to return to line 15, just like last time. We need one column for x, we need one column for y, one column for t. That has not changed. Column t is a local variable. We assume it is unknown. That has not changed. But what has changed is how we specify x and y. X and y are called pass by reference parameters because x is a reference to something. Y is a reference to something. It's a reference to what? Well, it depends on what you used to specify these parameters. I use m to specify x. So the way you specify the reference is you're referring to the column. You don't refer to the name of the variable, you refer to the column of that variable. So can someone tell me which column corresponds to m? C. Column C. Okay, so x is now a reference to column C. And y, likewise, is a reference to column D. That is why they're called pass by reference parameters. Okay, so I can pause a little bit here and give you an analogy, and then we'll take a short break, and then we come back and finish the trace, okay? So the difference between passing by value and passing by reference is kind of like this, okay? So let's say I want to check out a certain book from the library, so I can kind of read it and mark it up, okay? If I say pass by value, then I'm asking you to go to the library, make a photocopy of the entire book, okay? Give me the photocopy of the book, so that as a subroutine, I can make changes to the photocopy, but whatever I do is being done to the photocopy. It is not being done to the original book. Okay? So when I'm done, when the subroutine is done, I threw the entire photocopy into the recycle bin, and nothing happened to the book that is still in the library, because you made a copy of that book. Is that okay? When we are passing by reference, what do you think I'm giving you? I'm giving you a small slip of paper with only the call number of the book. It's a reference. Okay? It's an address. It tells you where to find that book in the library. Okay? So using the reference, I can now go to the library. Whatever I do to the book, I'm doing it to the original book. Is that okay? So when I'm done, what am I destroying? Because I have to destroy all the parameters. I'm only destroying that little slip of paper with the call number on it. Is that okay?
Okay.
A little bit?
Yeah.
So one is making a photocopy of the entire book. The other one is making a photocopy of just the call number of the book.
Okay.
And using the call number of the book, I can, as a subroutine, I know where to find the original book. And whatever I do is being done to the book, to the original book itself. That's passing by reference. Passing by value means the subroutine only gets a copy of the entire book. I don't even know where to find the book. Somebody gave me a photocopy of the book. I do whatever I want to the copy of the book. When I'm done, I toss everything into the recycle bin, so the original book remains untouched. Okay? So we'll take a 5-minute break. It's 53 right now, so we'll come back at 58. And I'm going to pause the recorder.
Probably want to pause your video.
So in terms of the video, it will be 2 clips, but I can splice my audio recording into 2 halves and line them up accordingly.
Do you mind if I ask what program you're using to do that?
I cannot remember, but I'll find it.
Okay. Let me know if you're. Let me know when you know.
It might be already installed here.
This is Audacity.
Not Audacity.
Yeah, Audacity only works with audio.
I think one is called AV Demux.
What's it called?
AV Demux.
Oh, I think I've heard of that.
AV Demux. AV Demux. There we go. So,
Okay, so it's a real
AVI Demux. It's basically AVI is a format that Windows uses.
Yeah.
But this particular program can also be used to combine an audio source with a video source and spit out the output.
Yeah, it's pretty much not more complicated than like just putting like API is a container format, so
Yeah.
you want the video and the audio, you just put them together.
Yeah, but it also allows you to kind of slide the time so they line up, and then you clip, the garbage from the beginning and
Okay.
clip the
So-
end.
It's about as complicated as like Windows Movie Maker then.
Kinda.
Maybe less even.
Yep. Yep. There are a few programs that I can use. I've done this before, so.
Yeah, it's just, I
And that's-
think it's interesting that you're doing it on Linux, because video editing on Linux is something else.
It worked okay.
Yeah, there's
And this-
actually a couple good programs.
That's also the reason why I'm putting on my Bluetooth headset. So this is actually the microphone I'm using right now. I think the recording software knows to use the Bluetooth headset instead of the built-in mic.
Oh man, that's gonna sound good then.
Maybe.
Well, I think Bluetooth headsets tend to sound pretty good.
All right. Okay, so final exam. We do not use the final exam schedule. That's only for full semester classes. So with this class, December 12th is the day of our exam. So we'll take the final exam on the 12th of December at the same time that we have our lecture. It's going to be a 2-hour thing. So I'll give you guys 2 hours and 5 minutes, the entire time of the entire lecture. So from 6 to 8:05 is going to be our final exam on the 12th. Is that okay?
That's a long exam.
Well, all exams are 2 hours long. You can see, on the finals week, every single exam is 2 hours long.
But if you finish it earlier, then you finish it earlier.
Yeah,
Exactly.
Yeah.
but
Some people may choose to give up, but but that's your choice. I mean, it is entirely your choice.
Last time, wasn't it just the first hour that we took things at?
Yep. Yep, that was just 1 hour because it's a midterm. And we do not have a whole lot of time for lecture anyway, so that's why I did not use the entire 2 hours. It wouldn't make sense to have a 2-hour midterm. All right, so let's go back to the trays. Yep, that's recording. And, all right, so here's our trays. So the key part of passing by reference is a pass by reference parameter is a reference to a particular column. Whatever you use to specify the parameter, whatever column M is using, X becomes a reference to that column. Okay? So when you look at parameter X, you would not even know the name of the local variable that column C was corresponding to. Okay? That's the idea. Okay? It tells you where to find the column. It doesn't tell you the other name of that column. Okay? So getting back to the analogy, passing by reference is giving someone a call number to a library. So you're telling that person how to find the original book. Every work that you're supposed to do is being done to the original book. Passing by value, on the other hand, is making a photocopy of the entire book, and then you give the copy of the book to someone to work on. But that book is, because it's a photocopy, by the time that person is done with that photocopy of a book, it has to be tossed into the recycle bin. Is that okay? So we'll go ahead and work this out first, and as we work this out, you guys can ask questions. So after line 14, after we set up all the columns, we get into the subroutine, starting on line 5. So on line 5, we are going to store x to t, okay, at least that's what the pseudocode is telling us to do. X is a reference to column C. So x does not actually have the value that we want. It is only containing a reference, a way to find the value that we want. So we go to column C. Column C has a value of 15. That is what we are going to store in T. Do we have any questions about this particular step? So T is not a reference to column C. We do not copy the reference to a local variable. We copy the value of the column referred to the local variable T. Is that part okay? Okay. So we now move on to line 6. Line 6 is a little bit more interesting. The right-hand side kind of works out the same way as before. We look up y. Y is a reference to column D. Column D has a value of -20. So that resolves the right-hand side of the assignment. The left-hand side of the assignment is x. So we say, okay, we want to store -20 to x, but we cannot store into a pass by reference parameter. It would not be correct. Okay, so once again, do not copy this. Okay, this would not be correct. This is not what we need to do. Okay, so we get rid of this. Okay, come on, click.
So when you say don't copy that, you mean you're just writing it down like as an example, and that's not what we should notate? Or am I misunderstanding?
I mean, this is not what you should be doing.
Okay,
Okay, so get rid of that. Okay,
all right.
if you have a pass by reference parameter, the parameter itself does not get the update. What it refers to gets the update. So in this case, it is column C that is being updated to -20. Is that okay? This is the big change compared to the previous example.
I think I get it.
The parameter itself doesn't get updated. the column that it refers to gets updated. Is that okay? All right. So if you understand line 6, line 7 is pretty easy. Line 7 has t as the right-hand side. T has a value of 15, and we are copying 15 to y. Once again, y is a pass by reference parameter. We cannot change the parameter itself. We changed what it refers to. It refers to column D, so it is column D that is updated to 15. Is that okay? Okay, all right. So now we get to line 8. So you might ask, well, what are we going to do to those parameters on line 8? We deallocate, just like before. So the way we get out of swap is the same as last time. We look up the rightmost return line number column, column E. It tells us to go back to line 15. So we say, okay, we'll take note and to go back to line 15. And then we'll proceed to deallocate all 4 columns that were allocated for this particular subroutine. Okay, so there we go. And we'll deallocate all of these. So just like last time, we're deallocating x, we're deallocating y. But that's okay, because x and y are really just references to column C and column D. We are not deallocating column C nor column D when we execute line 8. Is that okay? So by the time we continue execution on line 15, local variable m and n of main actually got exchanged. Is that okay? This is a very useful mechanism so that a subroutine can change something that does not belong to the subroutine, and yet we are not using global variables. Is that okay? All right, cool.
So is this kind of sort of a way to establish more variables when you run out of names?
No. It is a way so that you can allow a subroutine to change only things that you allow the subroutine to change, only things that you want the subroutine to change. Okay? So line 15 itself, yeah, go ahead.
This would be a good way for like updating information in a program. So
Yep.
if new parameters are put in, that this would be updating the base code to let it know like these have changed.
Correct. So if you want a subroutine to update something, then you want to, there are 2 mechanisms to do it. Passing by reference is one way to do it, and then the other way is to have a return value, which we'll talk about next. Okay? But if you have multiple things that you need a subroutine to change, then passing by reference would be the better way to do it. Okay? So by the time we get to line 15, we want to deallocate, we want to make a note that we should continue execution at post, because that's what the return line number is telling us. And then we proceed to deallocate columns B, C, and D in this case. So copy and paste, strike through. And that concludes the execution of this particular program. Is that okay? All right. All right, so I can give you more examples of pass by reference. You can kind of mix it up with passing by value too. So not all parameters have to be one type. You can kind of have a mix of the 2. So I'm going to write another subroutine, okay, define transfer, okay, transferring money from one account to another account, okay. So we say by reference from, by reference to, and then we say by value, how much, okay? How much is a variable that indicates how much do you want to transfer from one account to another account. So the way we do it is we say from, get from minus how much, because that's where you're drawing the money from. And then to is 2 plus how much, because that's where the money is going. And define sub. So use indentation first. Here we go. And then we define sub main. I forgot about the word sub here, which is not strictly needed, but let's be consistent. So we have local var, local variable, tax account, tax wife's account.
Wouldn't it be the other way around? Oh, never mind.
So we'll say tax account starts with $20, and tax wife account starts with $40. So, and it will transfer. Okay, so we say invoke transfer. Okay, and when you invoke a subroutine with parameters, you have to specify every single parameter. So now I have to specify what do I want to specify, what do I want to use to specify from. So we'll say we'll transfer from tax account. So tax account is used to specify the parameter called from. Tax wife's account specifies the to account, and we'll do a $30 transfer. Okay, and define sub. So this is ending the main subroutine. Invoke main. There we go. This is not a finance class, so it's okay. If this were a finance class, this would be problematic.
It's a really interesting practical example of this though.
So line number 3, we got nothing to say because there are no global variables. And then the first line outside of the definition of a subroutine is line 15. We allocate return line number to go back to post, and then we have 2 local variables. So one is tax account, this is kind of long, tax account, and the other one is tax wife's account. And these are local variables, so they always start with unknown value, or we assume that we do not know the values of those variables. Then we continue execution in the subroutine on line 11. Tax starts with $20, and tax wife starts with $40. And then on line 13, we invoke the subroutine. We transfer money. So once again, we allocate a return line number column. When we get back, we should return to line 14. And then we have the 3 parameters. We have the from, we have the to, and we also have how much. The from being passed by reference has to be a reference to some column. Okay? In other words, you always start with refer to column something. Okay? That will really help to remind you what needs to happen here. Now, what did I use to specify the from account? Well, tax account, right?
Column C.
Tax account is column C. Very good. So here we go. And this one is column D. And then this one here is, because it's passed by value, what should I put here? How much? Should I say reference to column something, or just 30, right?
That's the parameter.
Okay, just the value itself, okay, because it's passed by value. So this is how we set up the parameters. Once we set up the parameters, we follow this code here inside the subroutine on line 5. So on line 5, 20 minus 30 is negative 10. So now I owe the bank money. And then on line 6, we add 30 to 40, so that's 70. And then we're done. Okay, so on line 7, we conclude the execution of the subroutine, which means we got 2 things to do. We look up the rightmost return line number. It tells us to continue execution on line 14. Make a note of that. And then we deallocate every single column that we allocated for this invocation. Copy and paste. Mark it up. And now we continue execution on line 14. So, yeah, I would say it worked. Okay, we transferred the $30, even though I end up with a negative quantity in my account. But once again, this is not a finance class, so it's okay. Do we have any questions about this code? What, yeah,
I just, I'm still like, I didn't get to finish writing down what the code itself was in my notes, so I just want to see that window, yeah, thank you. Just need a second with that.
so as you're writing that down, what do you think is gonna happen if I specify tax account, both to the from and the to parameters? Do you think that's gonna work or not?
It'll be a loop.
It's not, we'll check it out, okay? So we'll go ahead and check it out next, okay? So we'll finish this code, which is relatively, okay, Izzy, are you done?
Sorry, almost.
Well, it's gonna be recorded, so,
You can move on if you want.
okay. You can take a picture too.
I just kind of would rather have my notes in text, but I want to hold up the class.
All right. Thank you. All right, so on line 14, we are going to deallocate the columns used up by main. So that would be these 3 columns here. But before we do that, we have to take a note of where to go back to. It's post.
I got it notated now.
All right. Well, it kind of works out here. So copy and paste, and then we'll denote that all of these are now deallocated, and we're all done. We're at post. Is that okay? All right. So we're going to take the same program, but this time I'm going to say I'm going to transfer $30 from my account to my account. There we go. That's the only change to this program. I'm transferring $30 from my account to my account. The question is, what is going to happen to the trace? So we'll check this out. It's nothing surprising. By the time we get there, you guys will go like, oh, okay, no big deal. So we got line number, nothing to say about the precondition. Line 15 is the first line outside of the definition of a subroutine. We allocate 1 column for the return line number, 1 column for tax account, and 1 for tax wife's account, because I haven't changed that part of the program. The return line number is post. Tax account has an unknown value, and my wife's account also has an unknown value. We get to line 11. My account gets initialized to 20, get to line 12, my wife's account gets initialized to 40, and then on line 13, we'll try to figure out what's going to happen here. Return line number, not surprising, line 14 just like last time, so that one we kind of know. From is a pass by reference parameter, to is a pass by reference parameter, and then how much is passed by value, and we know that's just 30. So the big question is, what is from? Well, what did I use?
Don't think I'm at, seems like the 2 that are local to here close at 6:30.
6:30?
The one that helped me out closes at 7.
The one that, this is going to be in the West Sacramento warehouse. So it's not a UPS outlet. It's going to be the main UPS sorting facility. It's the West Sacramento one. I know they open till at least 6, if not 7. I think the latest one I have picked up is actually at maybe 9 o'clock even.
Wow.
Yeah.
That's
So-
on 8th Street. On Harbor, it closes
Yeah, Harbor.
at 6:30.
6:30, okay. That will give me a little bit of time tomorrow to pick it up. All right, well, not bad. I mean, it recovered all of this stuff here, and that's sheet 10. And that is, okay, it lost the last 2 tabs. Or maybe not, let me see. Yep, it lost the last 2 tabs. So basically, if I use tax account for both, what's going to happen is it will first deduct, so this will still happen, and then the next one is going to add $30 back to tax account. So tax account will go from 20 to -10 and then back to 20. So is that okay? I mean, is that explanation sufficient? All right. So let me restart the browser. So that's not too bad. I only lost 2 tabs of the spreadsheet without saving anything. And then in terms of the browser, I think the browser would ask me to recover because it knows it crashed. Yep, restore pages. There we go. That's the exam schedule. And this is the module. But that's not the one we are on. Nope, that's definitely not the one we are on. Nope, this is the one. So basically we are now at, we are done with passing by value versus passing by reference. Do we have any questions about both of those concepts? Okay.
I think I have a question.
Yep.
So like we were using the bank accounts example, right?
Mhm.
So like when you were using the metaphor of like taking a book and making a copy of it, in the case of the bank account example, the book would be your bank account, right?
Mhm.
That's what we would be creating an instance of to change or directly changing depending on if we use by val or by ref.
Well, the account, so-called account, is nothing more than an integer. So the by reference is basically a reference to the column containing that integer.
Right. Yeah, that's what I mean. I was just kind of using layman's terms, but yeah, that's
Okay.
Okay, I think I understand.
Okay, cool. All right, so if these two concepts are okay, we're going to move on to returning values, okay, which is this particular module. And I also changed the format of the trace so it looks more consistent to what I'll be using in the class. Nope, that's not the one. It is returning values. But is okay, it is the correct one. Okay, so here's the trace. The trace is already modified to reflect the way I'm going to use it. If you watched the video during the break, you would have seen this trace already. This is not new to people who watched that video.
But the video is still there, right?
It's still there. I could have taught this class just by clicking on YouTube. That's always a comforting thought, right? I mean, I can just go to class or send someone to the classroom and just start up YouTube and click a button.
Yeah, I mean, it's always good when you just automate, whatever. That's why computers are great, right?
All right, so give you the pseudocode first, and then we'll figure out what's going to happen. So we define a subroutine called 5, okay? And all it does is to return the actual number value of 5 and define sub. Define sub main. Main has a local variable x. X gets the result of invoking 5. And define sub. Invoke main. Okay, so we'll see what happens when we execute this program. So this one's going to be interesting. Or the way it's going to be traced is going to be interesting. How many people have some exposure to programming prior to this class? Okay, some of you. Okay. But even if you have exposure to programming prior to this class, this probably will be the first time you see the concept of returning a value explained in this particular fashion. Okay. All right, so we'll start to trace the program again. Line number pre has nothing to say because we do not have any global variables. X is the only variable in this entire program and is a local variable. So we don't have any global. The first line out of the definition of a subroutine is line 8. Okay. So we start with line 8. And because it's invoking a subroutine, we automatically have a return line number, this time to post. Okay, nothing surprising here. It has a local variable called x. It has an unknown value to begin with. Hopefully that is not surprising either. And then we continue execution in the subroutine. So we now go to line 6. Ooh, line 6 is kind of new because we are now looking at a line that has invoke 5 as the right-hand side of an assignment statement. Okay, that's kind of new because every single time we have used invoke or calling a subroutine in this class, it is all by itself on a certain line. It's never really a part of something, but this time it is. Okay, so we'll say, but what do we do now? I cannot use return line number. Okay, the reason why I cannot use return line number is which line should I return to when 5 is done? Should I go back to line 6 or should I go to line 7? If I go to line 7, that means the assignment is not going to work because I have not done the assignment yet when I'm done with the invoking of the subroutine. If I go back to line 6, it means I'm gonna do this all over again, which is also wrong. Yep.
Wouldn't it be 3? Would it be 3?
Would it be 3? What do you mean by?
Wouldn't you, if you're invoking 5 assignment in X, wouldn't you need to get into the subroutine of 5 first?
We need to get into the subroutine 5. The question is, when the subroutine 5 is done, where should I go back to? That is the question.
6.
So,
6.
but if I go back to line 6, then I'll be doing the whole thing all over again because I don't know which part of line 6 still needs to be done. Okay, that is the key part of returning a value. In other words, when the subroutine returns a value, like 5 in this case, the entire invocation is a placeholder. It has a particular value that can be used just like any other value. Okay, so the way we denote this, okay, I know this is going to be a little bit confusing, is we don't use return line number anymore because it is not just the line number that we need to remember. It is what we need to get back to. I'll just call it return information or return info. And the way we denote that, or what we need to do when we get back, is we say we need to get back to line 6. But what do we need to do on line 6? The assignment to variable x still needs to happen. What are we going to use to change 6? To change x? That is unknown. So that's the way I use to denote returning, how to return from a subroutine that returns a value. Is that okay? So return info is not only telling me which line to go back to, which is line 6, but it also tells me what else on line 6 do I need to do. Is that okay? Sure. All right? Okay. Then we go into the subroutine. The subroutine only has one line that does anything useful, which is line 2. Line 2 is a return statement, which we haven't seen before. This is the first time we see a return statement. The return statement, when the value to be returned can be determined, which in this case we can, because 5 is 5, okay? There's nothing we need to do with 5, is we look up the rightmost return info cell, we copy and paste it, and then we change the question mark to whatever value we're returning, which in this case is 5. And that's it. That's all line 2 is going to do. Is that okay? Yep, go ahead.
So the return info thing only happens because of the fact that we use a return
Statement, correct.
Okay.
It's because 5 has a return statement, then we have to use return info instead of return line number. Now, generally speaking, you can always use return info instead of return line number. Okay, I'll talk about that later. Okay.
Okay.
But the key part here is when we execute line 2, we are not changing column C. All we are doing is we are replacing the question mark, which is a placeholder, with a particular value. That's all we're doing. Is that okay? So this is the job of line 2. Line 2 is done. Then we move on to line 3. Line 3 is a very typical end of the subroutine. But in this case, we look up the return info And what we do is we copy and paste the entire return info over here. In other words, we go back to line 6 just fine. But when we get back to line 6, we know what else we need to do on line 6. We can finish the assignment statement now when we get back to line 6. Because the invocation of 5 is done already. Is that okay? All right? And then the second thing we have to do is to deallocate the column, which is kind of the usual thing that we have to do. So now we get back to line 6. But when we get back to line 6, it is not the line 6 in the original code because the invocation of 5 is already done. We know what the right-hand side value is. It is just the numerical value of 5. So now we can proceed with the assignment operation, which is to change the local variable x to whatever the right-hand side is. So x is going to be changed to a value of 5 in this case. Then we get to n define sub again on line 7. Yep.
Why don't we use a comments column to do the assignment?
Because this can be a lot more than just an assignment statement. The comments column, I reserve it to only indicate the evaluation of a comparison or something that is Boolean in a loop or conditional statement. And this is neither.
So if we were using like an expression for the return value or for line number 6, we still wouldn't use a comment?
Say that one more time.
If we were to use like an expression for line 6 as opposed to an assignment value, would we then use a comment line or column?
Give me an example.
X equals x plus return or invoke sub 5.
So the equal is a comparison equal,
Yeah.
but that has to exist as the condition of a conditional statement or loop.
Oh, okay. So in this case, it wouldn't matter.
Right. Okay. So line 7. So let's finish this one, and then I'll give you more examples. On line 7, we are at the end of the main subroutine. So this time there's really nothing surprising because this is a regular return line number. So we say, okay, we'll get back to post, and then we have no use of these two columns anymore. We'll deallocate both of these. And now we continue at post, and we are done. Is that okay so far? Okay. So let me give you another sample program that has the same kind of stuff. So we'll say this time it is define sub less than. Okay? And as you probably would expect, we need two values to compare to see whether the first is the less than the second. So we have 5L x, 5L y, and we return x is less than y. Okay? And define sub. So this one is going to look awkward, but the reason why I use this one is because I want to show you what you can, in what context can you invoke a subroutine. So define sub main. Okay, we'll say if invoke less than, and then we can use constants for x and y. So we'll say 5 is used to specify parameter x, and we'll say 8. Let's make it less. So 3 is used to specify parameter y. Then print. Okay, we'll just say print less than in this case. Else print not less than, and if. So this program doesn't even have a main because it's kind of not the main point of this code. Oh, it does have a main. Okay, fine. And define sub invoke main. There we go. We'll do some indentation first. The block indentation is something that Google spreadsheet cannot do. So that's one reason to use LibreOffice instead. There we go. And then we'll see what happens when we trace this code. All right. All right. Line number, precondition, got nothing to say. There are no global variables in this program. The first line outside of the definition of a subroutine is line 13. And we call main here. Okay, so if you want to, you can actually use return info here, okay? And you still say post, okay? There's nothing to do with post. So return info versus return line number is gonna give you the same thing. It's not gonna get you anything more or less. Then we get into the subroutine starting on line 7. Now it becomes kind of interesting because the invoke is taking the place of the condition of a conditional statement. But I cannot determine which way to go until the subroutine returns. Okay? So the invocation of the subroutine itself becomes a placeholder. And so like, well, somebody's going to have to tell me what this question mark is going to be so that I can continue with the conditional statement to see whether I should go to the then part or the else part. Is that making any sense? So that's why in this case, the return info, oops, typo, return info, is to say, well, when the subroutine less than is done, we're supposed to go back to line 7. What else do we have to do on line 7? Everything except for the invocation. So we still have the if, the placeholder, the question mark, is replacing the invocation that I'm dealing with right now. And then the rest is just copying the rest of the line. Is that okay? And then we have parameter x, we have parameter y, they're both passed by value. So x starts with a value of 5, y starts with a value of 3. So let me finish formatting the columns first, and then we'll ask, do you guys have any questions? So a subroutine that returns a value can be done at any place where the returning values can go. So if this subroutine can return a value that is either true or false, then any place you can expect the value of true or false can use the invocation of less than. Is that okay? If a subroutine returns an integer, then any place you can expect an integer, like on one side of the addition or subtraction or multiplication or division, you can use an invocation. It can take the place of any place where an integer can go. In this case, the invocation of less than can take the place of anywhere where true or false can be expected. The condition of a conditional statement is one of the many places where a true-false value can be expected. Yep?
Just to rephrase, make sure I understand it. So basically what you're saying is line 7 is asking to evaluate 2 separate parameters that we give it to determine whether or not they're less than or less than or...
The subroutine is going to do it.
Yeah,
Yep.
And then the return result is whether or not the screen will print less than or not
Correct.
less than.
So the conditional statement on line 7 is going to utilize the return value of less than in order to determine should we go to the then or should we go to the else branch.
And then we can use that subroutine any other time that we ever need to compare two parameters.
Correct. Yep, exactly. So now we go into the subroutine, which is on line 4. And remember, when you on line 4, you have to find out, can we evaluate that expression? Do we know what is x? Do we know what is y? Do we know how to compare x and y? The answers are yes to all 3. So we can say, well, x is 5, y is 3, 5 is less than 3 is false. So you're basically returning a value of false. What do we do when you execute a return statement? You locate the rightmost return info cell, you just copy and paste it, and then you change the question mark, which is nothing more than a placeholder of the invocation of a subroutine, with the value that it is returning. In this case, it is false. Is that okay? And that's all it's going to do. Okay? So at this point, we are not saying, oh, so that means the next line to execute is line 10. No, we do not make that determination. It is not the job of line 4 to decide where to go. The job of line 4 is simply to replace the question mark, which is a placeholder, with the value that we are returning. That's all it needs to do. Is that okay? All right?
Yes.
Okay, great. It's good to have that confirmation. On line 5, we're done, okay? So it has got 2 things to do. So at this point, I'm going to be a little bit lazy, so I'm not even going to copy and paste. I'm just going to say this cell is that cell. Okay? And then we have no use of these 3 columns anymore. So we basically copy and paste this whole thing and then strike them out. Now we continue execution on line 7. But when we continue execution on line 7, the invocation is already done. We already know the condition is false. So now we can actually make that decision of where to go next. Because if the condition of a conditional statement is false, we go to the else branch if one is specified. So now we can say, oh, okay, we know where to go now. We need to go to line 10 next. So line 10 doesn't do anything really particularly useful. And I forgot to use a comments column here where it is actually needed. So I will insert it to the left. And comments. So the comments that I have to put here is going to be pretty obvious because I have to say false is false. Oops, typo. Because the return value is already false. And I'm just stating, oh, the condition is false. So that's why we end up on line 10. And line 10 is going to print not less than. So missing a quote. Here. There we go. And then we go to line 12, which ends the main subroutine. So the main subroutine is now done. We have to go to post after this, and this column is now deallocated. Okay, format. Oh, wrong type. Strike through. There we go. Okay. So do we have any questions about the execution of this program? The invocation, the entire invocation, is replaced by a single question mark as a placeholder. Let's have one more example. This time we'll have 2 invokes on one single line. So we'll define 5 to return 5. Okay, define sub 5, return the actual numerical value of 5. To make this subroutine more effective, I should have used something other than 5 itself. Yep.
Can returns be anything? Integer, string?
Well, for the purpose of this class, we'll just say that we don't care about the type of the return value for now. Okay. We'll have this one returning 7, which is returning the numerical value of 7. And by the way, both of these are names of characters. Johnny 5.
Short circuit.
Short circuit, yep. And 7 of 7. 7 of 9,
7
of course.
of 9 from a,
Yep.
from a Voyager.
Yep. Alright, so we have a local variable x, and we say x equals to invoke 5 plus invoke 7. There we go. 2 invokes on one single line, and they're both returning values. And define sub, and invoke main. There we go. Alright. So how many people think that you might have some idea of how this is going to go? Okay. So this program, unlike the other ones, is illustrating that you can only invoke one subroutine at a time. So there can only be one question mark in return info at any particular time. You can go back to the same line to deal with the other invoke later, but you can only have one question mark at a time. So we'll go ahead and take a look, see what happens here. Line number 3, nothing to say, no global variables. And then on line 11, we invoke main, return line number, or return info. Okay, we can just use your post as a return info. That's perfectly okay. It has a local variable x. There we go, starts with an unknown value question mark. Then we proceed to line 9. Okay, so line 9 is a little bit mysterious. It's like, well, we got 2 invokes on one single line. What are we going to do with this? Pick one to deal with first. It doesn't matter which one. You can work with invoke 7 first. Okay, some compilers actually can determine which way to go. It's not necessarily from left to right. Okay, so it's perfectly okay to handle invoke 7 first. It's not a problem. So let's say we do that. Okay, we want to deal with invoke 7 first. Yeah. Question.
If you took the operator and changed it to a minus or a divide, would it matter?
It wouldn't matter in terms of how the program, how the control flows. It would matter what you're actually going to store in X, but it's not going to matter in terms of what the program needs to do. Okay. All right. So what are we going to put in return info? We have to make a decision. Huh?
Sorry, I didn't interrupt. But is that because they're invocations? You just invoke the subroutines and then you're going to add them later?
Yep. Exactly. So it doesn't have. We don't have to invoke 5 first. We don't have to invoke 7 first. It's just kind of like a coin toss. Okay, which one you want to do first is fine. So we'll just say that for whatever reason we want to invoke 7 first. Okay. So what we need to do then is to say when 7 is done as a subroutine, we have to go back to line 9. What else do we have to do on line 9? We still have the assignment that needs to be done. 5 still needs to be invoked. But 7 is resolved to a particular value. What value is that going to be? I don't know yet. I haven't invoked the subroutine yet. So it's a placeholder. Is that okay? So that's what we're going to specify when we get to line 9 the first time. So now we go into subroutine 7, continuing execution on line 5. Line 5 is saying return a constant of 7. What do we do with a return statement?
So 9:x, the assignment of invoke 5 plus 7.
Yep, exactly. So it's a little bit cumbersome if you're doing this on a piece of paper, because all we're doing is replacing the question mark with the value that we are returning, which is 7. So in an exam, okay, and you say, okay, I don't have time to do this, what you can do is to strike out the question mark and replace it with the value that you specify and just use an arrow to say that I'm changing that to 7. Okay, so that can save you a significant amount of time because now you don't have to copy the entire thing. Yep.
Is there a reason why we don't just kind of bump up line 5 to line 5 on row 6 and just automatically make that assignment?
Because you might have a significant amount of code to execute before you get to the return statement.
Okay.
Yep. Because I can have between 8 and 9 here, with an actual subroutine, you can have like 20 lines of code. So whenever you get to the return statement is whenever you change the question mark to the value. Okay? So this is line 5. Line 5 is done. All it does is to change the question mark. That's all it does. Then we get to line 6. Line 6 has got 1 thing to do, 2 things to do. It has to denote where we are going back to, but where we're going back to is no longer just a line. We have to say what else on that line do we need to perform when we get back. Okay? And then we have no use of this column anymore, and then deallocate it. Now we're back to line 9. But when we get back to line 9, it is a little bit simpler than last time because one of the 2 invocations is now resolved. We now have to resolve the other invocation I still cannot perform the addition because I don't know what 5 is going to return. So now we have to handle the other invocation. So reallocate column D to return info. And then this time when 5 is done, we still have to go back to line 9 because the assignment is not done, the addition is not done. So we have a question mark here in place of invoke 5, but 7 is already done. Is that okay? So now we continue execution in the subroutine 5 on line 2. Line 2 says return 5. When you execute a return statement, all you're going to do is to replace the question mark of the rightmost return info cell with the value that you're returning. So in this case, we are just replacing the question mark with the value of numerical value of 5. That's all we're going to do. Oh, but tech, I know 5 plus 7 is 12. Can we change that to 12 here? The answer is no. Okay? We are not executing line 9. We are executing line 2. The job of line 2 is really just to change the question mark to whatever value you're returning. Okay? So we're done on line 2. Now we get to line 3. Line 3 has 2 things to do. The first thing is to denote where we're going back to. We're going back to line 9 again. Okay? Second thing we have to do is to deallocate a column for return info. Now we continue execution on line 9. But this third time that we get back to line 9, we can now finally finish the addition and then the assignment. Because now we can say, oh, we know what is 5 plus 7. This is when we calculate 5 plus 7 is 12. But since we know what 12 is, we can also finish up the assignment operation. So this is when we update variable x. So variable x is updated at this point to 12. And then we can finally move on to the next line of line 10. So do we have any questions about this particular example? I mean, the rest of the code is almost the same as the previous one. The tricky part is, what if we have multiple invokes on the same line and they all come back with some values that we have to do something about? The answer is we handle one at a time. Yep.
Is the main goal of this just to avoid using global variables?
It avoids the use of global variables. It's also avoiding the use of passing by reference. Okay, you can see that there are no variables involved with the subroutine 5 or 7. And then the other thing that's nice about this is you can utilize the result of a particular subroutine immediately, and you can even pass it as a parameter. Okay. So we'll finish this first, and then I'll give you. I'll send that one to you as an announcement, which is going to be something for you guys to track before the class on Wednesday. Yep, go ahead.
So with just say, like, for example, the define sub 5 with a return of 5, that subroutine is a lot safer than trusting using global variables.
Correct.
Or pass by reference.
Yep. Okay, I'm not sure whether this is a good place to mention this, but I used to go to an Anglican church, elementary school, middle school, and high school. So we have to say a prayer, every other day. The reason why I brought this up is, for anyone who pray, okay, you can add this to your prayer. Deliver us from global variables. I mean, yes, it is that bad, okay? It is that bad. Global variables can lead to a lot of buggy programs, and those things are really hard to debug. And I will tell you the reason. We got 5 minutes to explain that. Why do we call a global variable a global variable?
Because it can be accessed by anything.
Exactly, it can be accessed by any subroutine anywhere in the program. Is that okay? But do we know, which subroutine, just by looking at the interface or the first line of the definition of a subroutine, do we know which one is going to change a particular global variable? No. It is not a parameter, so we cannot tell, right? So now that you have global variables floating around, some subroutines will read the global variables, some will change the global variables, right? But since you do not know which one until you actually read the subroutine, you don't know which one is going to change, which one is going to read. That means if you accidentally have one subroutine changing a global variable without considering the effect of changing that global variable, the rest of the program can be severely changed. The behavior can be changed because of that. And then when the program behaves like that, it's because of global variables. Tracking down which global variable is at fault and which subroutine or subroutines are also at fault becomes next to impossible. Now you look at the sample programs that we use in class and go like, I don't see any problems with that. We only got about 15 lines of code. Not a problem, right? Well, imagine 5 million lines of code. Okay? And you have thousands of subroutines. Then it gets a little bit difficult to track. Okay?
Plus, like when you're giving us these examples, they kind of exist in like a bubble, like we're having our handheld, but if we were out there making our own software from scratch, like
Yep.
we're gonna be a lot more accident prone.
Yep. So that's why you don't want to use global variables. Okay? If you need to pass any information into a subroutine, use a parameter. Yep.
Wait, which case would you want to use the global variable?
Say that one more time.
In which case would you want to use the global variable?
Constants. Like pi would be a good use of a global variable. You define pi once to be 3.14 and then to whatever precision you want, and make it a read-only global variable, a const. Okay? Then it's a legitimate use of a global variable. Okay? Most other cases, you do not want to use global variables at all. If you can avoid it, don't use it. Now, there are cases where you cannot avoid the use of global variables. But this class is kind of far away from the cases where a global variable has to be used, because that has to do with interrupts and kind of low-level operating system concepts. When you're dealing with multi-threading, then you have to use global variables, because that's kind of the only way, or one of the very few ways, that your threads can communicate with each other. But we are not going to do multi-threaded programming in this class. So that is not a concern that we have to deal with. And that's why in this class, and even in 360, and even in 400 and 430, you should find very, very limited use of global variables that are not constants. Constants is kind of an exception to that rule, because if you say, I want to define pi as a constant, you don't need to redefine pi everywhere you go. Okay? Having one single definition of pi as a global variable is fine. That is not a problem. Question? There was a hand somewhere.
We use 310. You do multi-threading?
Sorry?
310, will you be using multi-threading?
No. No class that we teach here is going to touch multi-threaded programming.
Oh, really?
It is that bad. Because when you have bugs with multi-threaded programs, and it's because of the use of global variables, they can give you a different symptom every single time that bug is stepped on. And you cannot tell when it's going to happen either. With multi-threaded programs and you have a bug, sometimes it can happen every 2 minutes. It happens very frequently. And then suddenly, nothing happens for 2 years. And you ship the product out, you ship thousands and thousands of your products out, and then it happens every week again. Okay, so that is the kind of problems that you have to deal with when you deal with real-time, multi-threaded programming. Good stuff, very fun. Yep.
So the next assignment is actually graded or ungraded?
I'll think about it. But I will definitely give you something to work on, before Wednesday, because I'll give you an example, kind of like this, except it has nested invocation. So the result of one invocation specifies a parameter of another subroutine.
So that'll probably be ungraded, though, right?
Huh?
That'll probably be ungraded.
I'll make it ungraded because I think it's a little bit hard, but I want you guys to kind of work on it.
Make it graded.
Make it graded?
Take your time.
Or not. Taking it back. Okay.
One. Two. I need
Would it be possible to invoke an indefinite amount